So we're going to start anatomy and physiology off with the skeletal system. And this picture right here is from the bodies exhibit. It's showing the skeletal system and it's showing the muscle attachment to the skeletal system. So the functions of the skeletal system supports the body by providing a framework for the attachment of other tissues and organs. So as you can see in the image, we have the arm with the attachment of the biceps to the forearm and to the shoulder joint for the movement of your upper arm. And it serves as levers pulled by muscles in the movement. So you see right there that as that muscle contracts, it's going to move the bone itself. Now we'll get to the muscular system next. So first off, there's the storage of calcium and phosphate ions within bone tissue and fat within the yellow bone marrow. And red blood cell production occurs within red bone marrow. So our new red blood cell production occurs there, which we obviously know is important for transporting oxygen around the body. Now the skeleton also is protection for tissues and organs. So you can see that the rib cage provides protection for our lungs, our chest cavity with our heart. It's providing protection for our kidney, our liver, all these different things. Now you can see that some of them protrude. Obviously you can get hit in the liver and that could cause pain, but it's protected mostly by this skeleton. Now with a bone, compact bone is the densest part of the bone. Spongy bone is going to have the spaces between it, and the mineral structure of compact and spongy bone is maintained by cells called osteocytes. Now you've heard that term osteo. We hear it with osteoarthritis, osteoporosis, and we'll get into those later on in the unit. But osteocytes are the cells that make up the structure. So we see an external layer of dense tissue called periosteum contains the outer blood vessels and all the sensory nerves of the bone. So we see that we have blood vessels and all those going to the bone. The innermost layer is called the endosteum. So we see in these two images, we see the periosteum on the left and we see the endosteum on the right, and we can see the bony matrix, the osteoblasts, and all the parts that make up the bone. These layers contain osteoclasts, which can dissolve the bony matrix, and osteoblasts, which produce new bone. So the osteoblasts are going to be used to produce new bone. So we know that if when you're growing or to seal up a fracture in the bone, we're going to need those osteoblasts in order to do it. Now, you see the anatomy of a long bone. Many bones have expanded portions at each end called the ephyseus that are covered with hyaline cartilage. This is where the bone articulates with another bone, forming a joint. Okay, so we see that there's going to be cartilage to protect the bone. Now you see how the blood vessel moving to the bone, you can see that there's got to be blood flowing to this cartilage and to the bone itself, or else damage can occur. That's what happened famously to Bo Jackson. When his hip got dislocated, it caused the cartilage to go away, the bone to die, and he needed that hip replacement, which ultimately ended his athletic career. The proximal ephyseus at the end of the bone closest to the trunk of the body, and the diaphyseus is the middle, and the distal is the end furthest from the trunk of the body. Okay, so proximal would be closest. If you were to stick your arm out, proximal closest to the body, distal would be the farthest end of the body. All right. So we see these right here, the different parts of the bones. So we see the anatomy of these bones, and we can see the difference in the red marrow, the cartilage, and the breakdown of these bones as a person gets older. So infants have a lot of red bone marrow, and then the yellow marrow, it kind of grows until finally as an adult you have not as much red marrow. Your bones are more solid. So we see right here, this one shows the breakdown of what makes up the bone. So we have the spongy bone up top, compact bone, endosteum, medullary cavity, periosteum, and then we see the proximal and the distal ends of the bone. Okay, so proximal, you can see right here at the top, that proximal end appears to be the hip joint. If I had to guess, that would be the femur. It makes the most sense. That would fit right in there. So the femur is the proximal end, and then obviously the distal end would be the upper end of the femur, or the lower end of the femur, I'm sorry, that would make the top of the knee joint. So we see the microscopic anatomy of a bone. A bone tissue is divided into circular units called osteons. Thin calcified sheets form a ring-like lamellae. Each layer of lamella contains pits called lacunae, which contain the osteocytes. So we see that these right here, the rings of lamellae, and they contain lacunae, which contain the osteocytes, which are used to form new bone. The hollow center, called the central canal, contains the blood vessels, right? So that allows blood to flow to the bone. Each osteocyte is connected back to the central canal through tiny channels, okay? And then you see right here, here is the lamella, here's the osteocyte, and then we see all the different parts: central canal, lamella, lacuna, and there's the lacuna again. So it's showing all the different parts of the bone. Now this is really interesting about bone growth. So bones continuously grow throughout and lengthen throughout childhood up to about age 25. The embryonic stages of development, bones are much more hyaline cartilage, and this cartilage is gradually replaced by bone in a process called ossification. So do you see how this skeleton of an infant, you can see that the bones look like they're mostly cartilage, especially in the skull, and that's that soft spot that allows for the skull to pass through the birth canal so that it can shift and move. And then obviously that cartilage is going to form your skull as you get older, but that's that soft spot on a baby's skull. So ossification begins with osteoblasts forming spongy bone within the center of the bone shaft. And we see bone development proceeds towards the two epiphyses. So we see that right there as the bone is growing, bone growth. You can see that in the second diagram. And then finally, we see the last diagram as it's starting to solidify and ossify as it gets older. So we see right here, eventually the osteoblasts produce bones faster than the epiphyseal cartilage expands, and the epiphyseal plate closes, leaving behind the epiphyseal line. Okay, so that's the growth plate. The growth plate is where the bone was growing. So that's pretty cool. You can see the growth plate in them, right? So a lot of you have heard, when you break a bone, do they break the growth plate? Is that going to affect the growth of the bone in the future? But we can see that where they are and how it is affected.